Okay, everyone, thank you so much for joining. This is the third webinar in a series that the OSCAL Foundation has put on. Like the previous two webinars, this webinar will be recorded and made available for free on our website. So if you want to rewatch this presentation or want to share it with anybody, we'll make sure that both the recording and the slides are made available freely on our website shortly after this presentation in the following weeks. Today's webinar is about implementing OSCAL, and this is going to be a little bit more of a technical deep dive into what OSCAL is on a technical level and about what that means for you as an implementer, you as an engineer, a tech lead, or as an enterprise as a whole. We're going to give a brief overview of some of the technical background that this presentation presumes that you have, just so everyone can be at the same level. We're going to talk about what an OSCAL schema is, going to talk about what implementation of OSCAL practically looks like to you as an implementer. I'll take a chance to share some of the OSCAL generation and parsing tips that I've picked up along with other foundation members over the years. And then for the latter half of this presentation, we're going to introduce some guest panelists who have joined me to talk about their own journey in implementing OSCAL. And we'll have a chance to ask them some questions and have a conversation with the panel to talk about their specific experiences and thoughts about implementing OSCAL. So if you think of questions that you would like to ask of our guests while you're watching this presentation, please take advantage of the Q&A feature in Zoom, where you can go and submit questions for us to take a look at the end of the presentation. Before we get started, for those of you that do not know me, my name is Stephen Banghart. I am the technical coordinator of the OSCAL Foundation. That means that I lead our technical working group, who is working on the technical aspects of the OSCAL standard, implementing OSCAL, and improving, extending, and maturing the OSCAL models and standards over time. I got my start in OSCAL originally at NIST as part of the original NIST team that created OSCAL, and have been involved in the community ever since. And on the day-to-day, I'm joined by other foundation staff, as well as the rest of our OSCAL Foundation membership, which is an open membership, to continue developing and advocating for the adoption of OSCAL. If you haven't had a chance to be introduced to the OSCAL Foundation, we are a nonprofit organization that was founded to centralize and coordinate the larger industry and government communities around OSCAL and bring us all together into one forum and one collaborative community where we can help facilitate the adoption, education, development, internationalization, and extension of OSCAL. So let's go ahead and jump into our subject for today, which again is going to be a little bit of a technical deep dive into implementing OSCAL. First, I want to level set on a couple concepts and give you the definitions that I will be using throughout the conversation. There's often a problem in this space of terms being overloaded or being used in different ways. And I don't want to try and solve that problem, but instead I'm going to establish what some of the words I'm saying mean moving forward. First of all, when I say data format in this presentation, I will be talking specifically about a serialization format. So this is XML, JSON, or some other serialization format that allows you to take data and save it to either a file on your disk or in memory in the case of transmitting something across the wire. I'm going to use the word document several times throughout this presentation. And when I say document, I'm referring to that specific instance of information, whether that's in a file, whether that's in memory, whether that's on the wire. A document is a single contiguous instance of information. And I'm going to be using the word schema a lot. When I say schema, I mean a set of constraints that define a type of document within a specific data format. This is a semantic, usually, set of constraints that allow us to define types of documents. One of the examples I like to give of what a schema is, and one that's a fun little tidbit, is that Microsoft Word documents are actually XML documents. They follow a very specific schema that makes them Word documents, but their data format underneath that schema is actually an XML file. And also want to note that these schemas have to be defined somehow, somewhere, if you want to have interoperable automatic validation. That point is going to become important later, and I'll explain a little bit more about what that means later in the presentation. For now, I think this is a good set of information to go into this presentation with. And I want to note before we continue that this is going to be a approach to explain implementing OSCAL in a little bit more of a technical but an abstract sense. I mean, I'm not going to be recommending specific libraries. I'm not going to be recommending particular programming languages. I'm not going to be giving programming or specific software engineering advice. That is best left for a different forum. So if you do have those kind of very specific technical questions, I would ask to hold those questions, and there are forums that you can take those that I'll talk about at the end of the presentation. If you've seen our previous presentations, we talked about the 8 different document types that OSCAL has within it. We walked through each of these in the previous webinar. We called them the OSCAL layers. Each layer is specialized to communicate a specific kind of information. Those document types are profile, system security plan, component, component definition, assessment plan, assessment result, and plan of actions and milestones. We're not going to be talking about the information itself that goes into these different document types. The previous webinar is available. I would recommend you go and watch the recording of it if you'd like to learn more about it, or go to the various NIST documentation pages. Instead, we're going to be focusing on what it means to implement these document types in terms of generating them, parsing and reading them, and integrating them into our enterprises and tools. Specifically for OSCAL, we're going to be talking about XML and JSON as the 2 possible data formats. The OSCAL also supports YAML as well, but we're going to leave that out of the conversation today. It doesn't really have much impact on anything we're going to be covering right now. Also, theoretically, there's nothing stopping OSCAL from being in a different data format, as you might imagine if you're familiar with this concept. But we're going to be really honing in on just XML and JSON for this presentation. So let's say you want to implement OSCAL. You have been tasked with either investigating what implementing or supporting OSCAL might look like, or you have been tasked with directly implementing it. One of the places that makes sense to start to understanding what that means is to understand what makes an OSCAL document an OSCAL document. And that's going to be the OSCAL schema. As we talked about at the beginning of the presentation, the set of constraints that semantically define a given document. NIST, the creator of the OSCAL standard, provides these schemas as part of an automated release process that they operate on the official NIST GitHub repository. So depending on your particular implementation scenario, you might be interested in implementing JSON, you might be implementing XML. This largely depends on if you've already been using one of those formats in your other tools or the rest of your enterprise. More and more commonly, we see people focusing on JSON because it's a little bit newer, but there are many, many use cases for XML still. I provide links here in this slide specifically for you to go and be able to look at these, download and look at these schema files, which I highly recommend you do if you're starting on this implementation journey. You'll be able to follow those links once you get a copy of the slides in the future. This screenshot that I provided here is taken from one of those links. This is the actual files provided on the NIST GitHub. And we can see that these are the exact schema files that we might be interested in if we wanted to implement, for example, the OSCAL catalog document type. We have an XML schema file, which is XSD. We have a JSON schema file, which is in a format called JSON schema, fittingly. And then there's also a converter, an XSLT converter that is automatically provided by NIST, and something called a metaschema file, which I want to talk about a little bit. If you want to implement both XML and JSON, there's a couple approaches available for you. One is to implement both the JSON schema itself alongside the XML schema, do them both at the same time. However, a more pure approach might be to follow the metaschema file, which is a kind of level above both XML and JSON. And this metaschema file is the ground truth. It defines what an OSCAL document really is. Those XML schemas and JSON schemas are produced for convenience and for rapid development. But the truth, the specification, if you will, of what makes an OSCAL document that particular document is contained in this metaschema file. If you haven't heard of metaschema, I wouldn't blame you. Metaschema is a language that was invented and created by NIST and is a specific way of expressing document modeling in a way that is format agnostic. And we can take a look a little bit later at what that might look like. However, NIST also provides a pretty significant set of tools for free, again, open source on their GitHub repository, that allows you to automatically transform between the XML versions, the JSON versions, metaschema versions. And this can really help reduce the amount of complexity that you need to deal with as you get started on your implementation journey. You don't necessarily need to jump into this complex metaschema language. You can instead use the XML and JSON schemas that NIST provides. I do want to say that those XML and JSON schemas provide an excellent starting point. There are some constraints that cannot be translated from the metaschema definition of an OSCAL document to the XML or JSON schemas. There are not a lot of these constraints, but there are certainly some. What this means is that if you validate against one of the derived schemas, which is the terminology we use to describe the XML and JSON schemas, you are most of the way to being a fully compliant OSCAL implementation. There's just a couple extra pieces of behavior that you'll need to implement, and those come from these metaschema files. So if you want to take an approach that's more manual, that's more involved, fine-grained, granular, and closer to that technical truth, then I recommend that you start your implementation journey by downloading the NIST tooling, building it yourself, understanding what it's doing in terms of making the transforms from metaschema into the other schema types, and really starting at that ground level. If you're looking more to just get an implementation off the ground quickly, instead, I recommend that you start with either the XML or the JSON schema. So we understand, we're imagining that we are somebody tasked with creating this OSCAL implementation. We now understand what defines an OSCAL document. We know how to go and find the schema files that we need to understand what defines that specific document. However, there are capabilities above and beyond that that really define an OSCAL implementation. And at the highest level, I consider there to be three OSCAL capabilities. And anyone that is creating an OSCAL tool or an OSCAL system or adding OSCAL support to something is going to want between one and all of these capabilities. Maybe you have a specialized tool that just wants to do one of them. Maybe you want to do all of them because you're implementing a comprehensive system. It's helpful to talk about each of these. The first is you want to create something that can produce OSCAL documents that you're going to send to some external entity. This is really common in the compliance use case, for example. You might be interested in consuming OSCAL documents from an external entity. This one, if you imagine your compliance use case, is common on the other side of that compliance use case, somebody consuming the documents that you've produced. And the third is using OSCAL documents and the OSCAL data structures and data models internally. This means either internal to your tool or internal to an entire system. We're going to talk about what each of those capabilities really mean, but once you've identified the capabilities that your implementation needs, you have one of two choices for each of them. You can use in-house development, whether that's you as an individual or some team at your organization, to create the feature sets that you need to support that given capability. Or you can purchase a tool or system from a vendor. And for each of these three capabilities, those are the two paths that you can take to get there. Okay, let's talk about what these capabilities actually mean. The first, producing OSCAL documents to send to an external entity. What do we really mean by that? We mean that your implementation has to be able to collect information from somewhere, and this can be any kind of information that's relevant to your specific use case. Must collect that information and use that information to construct and populate a valid OSCAL document output. You're taking something in, you are producing a valid OSCAL document. And how do you know that you've successfully implemented this capability? Well, it means that your tool can produce an OSCAL document of a given type. You don't have to support all 8 types necessarily, but you produce an OSCAL document of a given type that passes all of the validation checks for that type, right? And that means that the document that you produced is able to be used by other implementations. If the document you produce passes all those checks, it means that it'll pass all the checks once somebody tries to consume it, and everything will work. When we say that you want the capability to consume OSCAL documents, that means that you need to take in and parse one of these aforementioned valid OSCAL documents, an OSCAL document that passes all of those validity checks, extract the information inside of it, and do something with it. Maybe that means you're displaying it on the screen for a human being. Maybe that means you're storing it in a database. You're transforming it into something else, or you're using it to automatically execute some number of command and control functions, for example. And we consider this capability implemented when you can consume any OSCAL document of the types that your tool supports, as long as those documents are valid. You'll see we'll keep coming back to this concept of validity and why it's so important when we are writing OSCAL implementations. The third capability that we identified was using OSCAL documents and OSCAL data structures internally. The first two capabilities were focused on external processes, consuming a document from somebody else, producing a document and sending it to somebody else. Maybe this means sending to a different tool. Maybe this means sending to a different enterprise, sending to a different organization or entity. Those are all external processes. There is a third capability that is out there and fairly common, and that is using OSCAL purely internal to your tool, internal to a system, or internal to your enterprise. And this means taking the OSCAL schemas, which define a way of formatting and laying out information, and using that as a guideline, as a way of aligning your internal data structures so that even if your data is not represented in an OSCAL document, your database is formatted in roughly the same way that an OSCAL document might be. You're persisting those data structures throughout elements internally inside of your tool or system. How do we determine whether or not this has been implemented? We can't really. We focused on being able to consume or produce valid OSCAL documents, and we can check that when somebody else gets your output or you receive somebody else's input. When we're working entirely internally, there's really no one to, if you will, hold you accountable. You can use those OSCAL data structures and OSCAL documents any way that you want. But there are some important considerations here. And I'm going to spend just 1 minute talking about this specific internal capability because I do think it's one that can generate a little bit of confusion when we talk about implementing or supporting OSCAL. Typically, when an organization or individual starts this implementation journey, it's best if they choose ahead of time how they're going to handle this third capability. Do they want to align all of their internal structures and databases with OSCAL? Or do they want to do some kind of transformation at the edges and keep their proprietary structures inside? We refer to these two different approaches. The first, using OSCAL internally throughout the whole process, as native processing. And the second, using OSCAL input, transforming it or using it to populate a different data structure and then exporting it as transform at the edges. And just to make that more clear, a tool that is an OSCAL native tool, one that processes OSCAL natively, uses OSCAL data models as the internal representations of information. So you get some input, and maybe this is an OSCAL document input, maybe this is some other input. You get a series of inputs, and they're all transformed and managed as OSCAL aligned internal data structures. And then later, when you output, you're outputting an OSCAL document. It's easy to output an OSCAL document because everything is already roughly in the right configuration and orientation to make that transformation easy. Taking this approach makes interoperability really, really easy. Even if at the time of implementation, you're thinking, I don't know if I'm going to be sharing my information with external people. I don't know if I need to have this interoperability component. Approaching your internal data structures in the OSCAL aligned way makes it really easy to add interoperability later. The other approach is this transform at edges implementation. And this is a tool that takes inputs and stores and deals with that information in a non-OSCAL aligned way. And then, either at the end of its process, it then transforms and rebuilds, reconstructs OSCAL documents. This approach often makes implementation a little bit easier because you can use the data structures that you're already familiar with or have already established. And you're just transforming using interfaces on the edges. It does make interoperability more difficult in the future. Sometimes this is the approach you have to take if, for example, you're retrofitting a tool or system with OSCAL support. You're just not going to be able to completely change the internal data structures of your tool or system that already exists. And so adding interfaces at the edges is the only really practical way of implementing OSCAL support. So I don't mean to say that transforming at edges is strictly worse. Sometimes it's the only choice, but there are some potential consequences of choosing that method down the road. So I want to spend a couple minutes talking about some tips for actually managing this implementation. So at this point, if you are this person who has been tasked with implementing OSCAL, you now have your schema files. You now understand how to parse and understand those schema files. You know how to use those schemas to validate a given OSCAL document or use it to generate a valid OSCAL document for capability 1 and 2. You've decided how you're going to align your internal data structures, either out of a choice that you make or necessity for your circumstance. And now you're actually digging into the process of programming this. Here's some quick tips. These are fairly high level, but I think they'll be helpful. OSCAL documents share a lot of schema definitions. If you get a chance to go and look at the full set of schemas that are provided by NIST, there's actually more than just one per document type. And that's because there's a number of OSCAL fields that are the same between all of the OSCAL documents. For example, all OSCAL documents have a UUID, which is a uniquely identifying value. They all have a metadata field, which contains a wealth of metadata information about that document. Those are the same across all OSCAL documents, all eight. Um, Taking advantage of this can make your parsing and generation a little bit easier because you don't have to re-implement support for these things once you understand that they're defined in a common schema. Properties and data types are also in this category. OSCAL defines a number of data types that can be placed in various locations in various OSCAL documents. There are various flags, properties, and fields that are all pulled from a shared definition. They're only defined once globally and then used in each of the different OSCAL document types. So definitely be aware of that and take advantage of it to save yourself some time and make things go a little bit smoother. Um, and there are in particular schemas with the dash common language at the end of their file names. That'd be a great place to start looking for those global definitions. The second biggest tip is that OSCAL is really permissive. It is designed specifically to adapt to your use case. What that means is that there are a number of fields that are optional. They're very optional. If you don't put them in, nothing breaks. If you put them in and put whatever you want in there, nothing breaks. You can produce a valid document with or without these custom properties that you add to the OSCAL document. This means that if you have proprietary or specialized or particular information that you want to make sure gets propagated as part of your OSCAL document sharing, you can just include them as props at the relevant location in the OSCAL documents. Downstream consumers of your files are instructed by the OSCAL standard to keep those properties in, but just ignore them if they don't understand them. So this gives you tremendous flexibility, both internal and externally, for using these documents. You can also attach raw data blobs in case that's ever a use case that comes up. We see this pretty frequently with specific use cases with OSCAL. There's a back matter field that allows you to hold base 64 blobs, which means you can really attach any kind of information that you want to, whether it be a string property or a 3 MB file. Third, OSCAL is very permissive. That means that there are sometimes some complexities in parsing. Um, when you are parsing an OSCAL document and you receive a number of these custom properties, custom links, and other fields, you're supposed to keep those if possible during parsing. But if you don't understand what that is, if the declarations of what that property actually are not well defined already by the standard, you're safe to ignore them. You can just skip processing and go to the next thing instead. If you're going to be using custom fields, either receiving them or sending them, coordinate with the organizations that you're going to be sharing with to sync up on what those custom fields actually mean. And I do want to note here that if you're using a custom field that has wide utility for the wider OSCAL ecosystem and not just your proprietary use case, come and tell us about it at the OSCAL Foundation. We'd love to get it added as an officially supported field. And my last tip here is to work your way up to full compliance. And this is a hint that I have to give with some caution to say that I strongly recommend everybody fully implement the OSCAL meta schema definitions that allow for your OSCAL documents to be fully compliant. I do think that that is the final end state of all OSCAL implementations to be able to do that. That said, to get off the ground quicker, it might be worth it to focus on the JSON and XML schemas first, or just one of them. Just focus on an XML schema first and only support XML documents of a certain type and work your way up from there. I think that's a better way to get started and to cover most of the constraints and validity checks that exist. Um, the last thing I want to cover is saying if not you're not developing a tool, but instead you've either already finished a tool or you've purchased a tool. How do you actually integrate that into your existing enterprise systems? And it's worth thinking about ahead of time, thinking about the places that you can plug these tools in, whether you purchase them or you build it yourself. Here I've created a diagram of some examples of what that might look like. Your OSCAL tooler system could take in manual input from a human being typing things into a field. It could be collecting enterprise posture data, such as that's automatically collected out of various cybersecurity automation platforms, or really any other machine readable data is all fed into your tool. Could be one of these things. It could be all of these things. And the tooler system will then output that, maybe as an example, to a visual display. It will use it to construct a compliance package, or it will use it to feed some security automation APIs. Down at the bottom, I've put in a circle for generative and agentic AI. I think that it would be a disservice to talk about a machine readable format without at least spending one slide on talking about artificial intelligence. So this is my one mandated artificial intelligence slide. And I do think that this helpful to consider. OSCAL in general is well suited to AI use cases. It's a well-structured, well-formatted, machine-readable language, which means that it can be used to train an LLM or other AI by feeding it the information that you've collected. And it's actually quite useful for that. Couple notes that are worth keeping in mind if you're going to go down that route. OSCAL is fully machine readable, but many of the fields inside of OSCAL are still in human readable text. And that means that a traditional AI that is focused on numerical values is probably going to struggle to make sense of it. And you may need a language aware AI like an LLM. And the other note I'll make is that if you are using an LLM, take care to pre-process your OSCAL documents first to make sure that you're not introducing any errors brought in by the specific text formatting of your data format. XML and JSON look a little bit different. If you feed them in wholesale to an LLM, you might not get the results that you need. You're going to want to process that OSCAL document first into its constituent pieces and use those. So, in conclusion, before we move to our questions and answers and our panel discussion, OSCAL is a great technology to take advantage of when you either have a want or a need to communicate between two separate entities in a way that is interoperable. And some of the most common use cases that we're seeing OSCAL being used in today is not an exhaustive list, certainly, is compliance management and compliance as code, risk management, and security automation. So particularly for those subjects, if you want to be able to communicate with other entities in a machine readable and interoperable way, OSCAL is a great technology to investigate. Using OSCAL internally provides a really useful way of organizing your data and information, with the added bonus of making it easier to convert into a machine readable, interoperable format down the road. And finally, if you do start your OSCAL implementation journey, the OSCAL Foundation hosts weekly technical meetings. We also have a mailing list where we allow members to send in questions, thoughts, really anything. If you have lessons learned, if you have experiences from implementing OSCAL, or if you have ideas on how to make it better, we would love to have you involved. I have a link here. OSCALFoundation.org is our website. And we have a page there, Get Involved, where you can join our working groups and join as a general member. Joining the groups and getting involved and providing technical contributions is free. And we welcome everybody to join and participate. So that takes us to the end of our presentation segment of this event, and we're going to move to a Q&A and panel discussion. So I would like to introduce my two guest speakers for today, and I thank both of them very much for being here and spending their time to talk to us about their experiences. First, we have Brian Ruff from Ruff Risk, cyber solution architect. And my second guest is Fritz Kunstler, principal security engineer at AWS. Thank you both so much for being here today and being involved in this. I really, really appreciate it. Um, Both of our guests today have had various experiences with implementing OSCAL, being involved with OSCAL, investigating and research the applicability of OSCAL. And I'm really looking forward to having a conversation with them and talking about some of their experiences. So I'm going to go ahead and open up our questions and see if anyone has submitted any. If any more occur to you while you are sitting and listening, please feel free to submit those questions, and we will get to them as long as we have time. Okay, so let me bring us front and center here. My first question to both of you is when I talked about the implementation of capabilities with OSCAL. You have these different capabilities that you can implement, and then you have a choice for how you want to see it actually implemented inside your organization. And those choices were to either do an in-house development effort and create a proprietary solution, or to go out and look at either purchasing a pre-made solution or bringing somebody in to make your proprietary solution. Um, I'm going to start with Fritz here. Could you speak to what you see as any potential benefits or drawbacks to these two different approaches to getting those OSCAL capabilities?
Sure. And thanks for hosting and for having me here today. Um, so I think I should start by saying that I see OSCAL really as a means to an end, right? It's pretty rare that OSCAL itself is going to be the capability that we're after. You're likely implementing OSCAL or pursuing, OSCAL as a feature of something uh, to deliver some other capability. And so, first, I would say focus on that capability that you want to deliver. Is it compliance automation? Is it some sort of integration within your larger GRC tool chain or document import export? I mean, could be any number of things. But focus on that, and then um, from there, the build versus buy calculus for OSCAL, I see as really pretty much the same as any other tech. Uh, I will say that I always um, start with open source first. I want to go out and look around, see what the open source community has built, and if nothing else, use that to establish a baseline that I can compare other things to. It still is going to open source, of course, still requires in-house technical expertise, but it may be more operational and business subject matter expertise than it is, you know, software development engineers. And it also comes with the benefit of fast and cheap proofs of concept at relatively low risk, right? Um, I imagine probably most folks here have a pretty good handle on the general technical build versus buy calculus, so I won't bore you with that.
Thanks, Fritz. Brian, do you have thoughts on the build versus buy for OSCAL capabilities?
Sure. First, like everything Fritz said, I'd echo all of it. I would say, OSCAL, the point of OSCAL as a data layer is interoperability. And similar to what Fritz said, you need to know what you're trying to accomplish with OSCAL, more precisely, what information you're trying to explain between which organizations or which teams or which tools. And that's going to really drive. I tend to not look at it as strictly build versus buy. Um, I tend to look at it as there may be some tools that that you need that are not available for purchase. You have no choice but to build. But then there's other tools that you may be able to make that build versus buy choice on. But it's an ecosystem that you're building. And so, at each point in the exchange process, you're going to have that micro decision for that point, build versus buy.
Right. So it sounds like it doesn't deviate too far from a typical software development build versus buy calculus. It's at the end of the day, a piece of software that you're procuring. Um, yeah, I think that makes sense.
I might add that also with any of these efforts, there's a strategy that you want to formulate even before you start to make any build versus buy decisions. For example, you could approach this like with a data warehouse scenario where OSCAL is the common format for the data warehouse, and then all the other tools are interoperating with it. Or you could have a distributed approach. So you need to be making decisions like that, I think, even ahead of build versus buy decisions.
So it's really more of a strategic approach rather than a single tactical decision.
Exactly. These are tactical decisions that fit into a larger strategy.
Sure. So on that thread, after you have made those decisions and you're now sitting down to implement in-house some OSCAL tools and capabilities. I want to talk a little bit about the different internal data alignment approaches, the difference between the native processing or OSCAL all the way through versus transform at the edges, importing OSCAL if you need it, exporting OSCAL if you need it, keeping everything inside either the same as it was or some standard data structure. So Brian, staying with you, do you have a particular feeling that one is more advantageous than the other? Are there pros and cons that balance out? What are your thoughts on that?
Sure. And you touched on this a little bit in your presentation, Stephen. The idea that especially if you have existing tools that maybe you're not OSCAL native, then you may have no choice but to speak OSCAL at the input and output, the import and export um, side of things. Even if you choose to build OSCAL aligned tooling, or adopt OSCAL aligned tooling, you still have that. Um, Import export side of things. And then this is a nuance here. As you mentioned, OSCAL is available in different formats, XML, JSON, YAML. Generally, there's not a tool that will do all three formats. The tool will do just one of those. And so even if you do an OSCAL native alignment internal to the tool, what you might still put at the input and output is the ability to convert to other formats. So if I'm native OSCAL JSON, then I might still handle native OSCAL XML and YAML by converting them on the input and output, and then do all of my internal processing as OSCAL JSON. So you're going to have that concept regardless. Um, building internal data structures to align with OSCAL does not have to mean um, using OSCAL native all the way through. It just means that your database structures or what have you were created with OSCAL alignment in mind. And we have seen tools that are trying to retrofit legacy that struggle a little bit more to align all the OSCAL data the way it's intended.
Yeah, Fritz, representing a larger organization that might have some challenges with retrofitting or integrating with existing things. Do you have thoughts on this native versus transform at edges approach?
Oh, yes. Do I have thoughts? Um, so I guess at the highest level, I'll just say that unless you're a startup or otherwise in a position to start from a blank sheet, I think the answer is that you're going to need to do both, right? And having said that, strategically, uh, native processing, as we've been describing it here, is that's my overall objective, right? And the reason, as Brian touched on before, really it comes down to interoperability, and I don't think So as long as we're talking about use of OSCAL in risk management or GRC, right? I think everyone agrees that GRC automation is really the only way forward, and that has got to the automation that crosses enterprise boundaries in order to include all of the relevant stakeholders, so the business, the auditors, regulators, customers, et cetera, right? And so I want every tool, every agent, every service in the entire tool chain to speak OSCAL so that I can avoid these sort of intermediate transformations from one format to another that lead to opportunity for errors, loss of fidelity in your data structures, and a host of other challenges, right? So I think also OSCAL really brings some benefits when it's natively implemented that you just can't get in traditional approaches. One of the big ones that we've seen is that OSCAL is very fine grained, and so when it comes to things like mapping exercises, you have this for the first time ability to make mappings between much smaller data elements than we might have in the past, right? Like a whole page or a section in a PDF just doesn't cleanly map to a whole page in a section or section in a PDF written by a completely different organization. And so I think there's big value to that. But to wrap it up practically, there's going to be value to your business, potentially, and to your customers that can be delivered much more quickly just by transforming existing artifacts from legacy document formats to OSCAL. I would just say when you go down that road, make sure that you can do it in a repeatable and consistent and inexpensive fashion. Because if you can't, you may well be moving out of the realm of quick win and into the realm of problems that you're going to have to resolve or tech debt, right? So hope that helps.
Yeah, that's a really great point, and it's something we see frequently that we wish everything, all the information was in OSCAL format already, but obviously in the world that we live in, that's not always going to be the case. And so there's always going to be some transformations somewhere to make things fit into the practical world that we live in. Um, and it's a great point to think about how you can do those in a way that is repeatable, as you said, and consistent, to try and move away from some of the hand-driven manual processes that sometimes get used today. So I want to ask about the ability of OSCAL to be flexible. We mentioned flexibility a couple times in the presentation, and we didn't have time to fully cover the nuances of what that means. But I think to me, that means the ability to add information that is unique to your given process to an OSCAL document and allow that information to propagate forward as you share that document forward. I'd love to hear your perspective, both on, are there use cases that you've seen where this flexibility was really useful for a given use case, where that ability to propagate custom information enabled some use case? And then B, maybe as a follow-up question after that, I mentioned the concept of being able to elevate some of these custom elements to wide use. So keep that one in mind. But first, I want to ask about flexibility and some use cases if you've run into any, or if you can imagine any. And Fritz, how about you go first if you have any thoughts on this?
Yeah, so I will say that I've not to date encountered any practical use cases that required extending OSCAL meaningfully. It is really a well thought out and sophisticated language as it stands, and I think that for me the biggest value so far, because I haven't encountered those use cases, is just the knowledge that it was intentionally designed for extensibility, and so I have the ability to do that in future, should it be necessary. I could probably talk for an hour about sort of speculative use cases and reasons why this is good and bad and whatever else. But instead of doing that, maybe I'll just defer to Brian, who perhaps has more experience in this area than I do.
Uh, Thank you. Yeah, so OSCAL was designed with the idea that the core syntax was the syntax that's generically applicable to multiple different frameworks, but then also has extensibility and other flexibility built in with the idea that, for example, the U.S. federal government tends to do qualitative risk risk rankings, low, moderate, and high, whereas the financial industry or insurance industry might do quantitative risk rankings where they're assigning dollar amounts. And so OSCAL was created with risk values in the assessment results in the POAM area, where you can indicate which risk metric types you're using. And then a machine that's processing that can see that, oh, this is a NIST RMF type, so we're expecting low, moderate, or high, or this is a financial industry type, so we're expecting some numerical value. Then OSCAL was also created with this idea of extensions, which are property fields that an organization can define extra properties. And these are all over the OSCAL syntax and namespace. And it's the idea that any place where core OSCAL doesn't offer a means to capture the data that you need to capture for your framework, you can effectively create fields in OSCAL using this extension capability. There's a way you apply your organizational namespace to that so that machines can then know, oh, this is some organization's extension of OSCAL, and then have some means to potentially go and look up how to interpret that organization's extensions. An example there, when I was with the FedRAMP PMO, there were a couple of elements that were specific to cloud computing that the FedRAMP PMO needed in a FedRAMP SSP that were not necessarily applicable to all forms of computing. And so there are some FedRAMP extensions to the SSP model to capture things like, whether the system is an IaaS, PaaS, or SaaS, or what the community model, what the user model is, community or private cloud, hybrid, that sort of thing. So there's use cases around. They're in various levels of being exercised well, but they're definitely there, and I do think OSCAL is living up to its intention of building that flexibility in.
So I think, Brian, you're a perfect person to ask this follow-up question to, given your experience. We've seen these use cases of organizations adding these fields or doing extensions or namespacing things in certain ways. We've also seen some of those organizations then come forward to the community and say, we think that this has a wider utility. We think that this has benefit or value beyond just us. And we want
Mhm.
this to be able to be supported by anyone else. Having seen this happen, both here in OSCAL and in other places, could you speak to a little bit what would be the threshold? What would be if I'm an organization that has these custom things, what would make me think that I should take this to the wider community? Are there any like indications, or any guidance or thoughts that you have there?
It's a great question. I can think of some specific examples. I'm not sure how much I can draw from those examples, a good guideline for when to come forward. I'm going to answer more generically and say there are a number of forums where the OSCAL community is communicating. The OSCAL Foundation is a newer area, means of communication. There are NIST hosts some mailing lists. And a Gitter. Well, it's not Gitter anymore. It's Element. There's an official OSCAL channel there. There's also an OSCAL group on LinkedIn. And I would suggest that if you have something that you even think has utility to a broader community, post in one of those communication channels and ask. And having said that, let me give one example of where I think that has come up, where uh, FedRAMP, again, when they ask for cloud service providers to respond to an SSP, they're looking for a very specific level of granularity for that response. So that, for example, if a NIST 853 control has a part A, B, and C, they want responses not for the entire control. They want responses at the A, B, and C levels. And so in OSCAL, OSCAL was missing a way to do that. So FedRAMP created something called a response point that it put into the OSCAL data under the FedRAMP namespace to say this is at the level that you should be responding to your SSP. That is something that in conversations, like different government agencies want responses at different levels of granularity. So we think that that's applicable more than just for FedRAMP. We also, in talking with other tool developers, it looked like, this is something that anyone creating a tool for authoring SSP content, that's an ambiguity for the tool. We have this control statement broken down to, A1, B2, C3. What level is the right level for response? Well, that response point becomes kind of obvious there. And so I think that's an example of something we're going to see at some point be brought forward as a promotion in the OSCAL standard, maybe make it an official property instead of an extension.
Sure. So I'm really hearing that, if you have ideas that you have even the slightest inkling that would be useful, that you should bring it forward to the community. And I agree with that 100%. Okay, we're starting to hone in here at the end of our time. So we only have a couple minutes left, but I want to ask a question that I think is very practically helpful for people here on the call. And I'll start with Fritz. I don't think I have to ask for you to imagine yourself as somebody that has had to go and look into OSCAL. You have done that. What would be your advice to the people on this call or watching this recording that need to go implement OSCAL? Whether you have one piece of general advice or if you have a specific resource that you found immensely helpful, or where you started, just a little bit of the lessons learned from your process that you can pass on.
Sure. It's a great question. I think where I started well, I started with the documentation. I am a person who likes to read the instructions, and so I started by reading the docs. I won't say that I've read every page in great detail, but I definitely start with the docs. From there, as I mentioned before, I try and move to open source as an example of sort of what's out there, what's been done to date, and I got a lot of benefit out of exploring IBM's open source project Trestle. And I would certainly encourage people to go take a look at that, not only for its capabilities, but also architecturally and in terms of the software design or implementation. It's a great example of that you can use as a starting point. More specifically, and to align with the point I made earlier about how I really want to see strategically all the things speaking OSCAL natively, I would just say if you're building software systems in this space, focus on the outcome, not OSCAL. But once you've determined that OSCAL, is makes sense, you really should work to influence others building in the same space to rule OSCAL out before you go devise your own data model for things. I haven't been involved in the OSCAL community for very long compared to my colleagues here, but I have to say I'm really, really impressed by the level of effort and intent and expertise that has gone into the development of OSCAL. And it's quite unlikely that anybody's going to be able to replicate with a short-term in-house effort that all of those things. Is designed intentionally as a stack of layers that makes it really modular and composable and easy to adopt incrementally. And so just please don't go roll your own thing before you evaluate OSCAL for this category of stuff, and ideally rule it out because the benefits are big.
Thanks, Fritz. I think that's a great answer and insightful. Brian, I only have like 60 seconds for you here. If you could give your 60 seconds words of wisdom to our live viewers and recording watchers on getting started with OSCAL implementation.
There's a lot of resources out there, a lot of people who want to talk about this and want to help you with it. I would say I can acknowledge that it's a little bit overwhelming to just look at the documentation without having some of the guidance. But it's worth the investment in time. Just reach out for help, and I think if you get started the right way, you're going to be happy that you invested in it.
That's a great answer as well. Thank you, Brian. And that brings us to the end of our third webinar. So again, I'd like to thank my two guests, Brian and Fritz. I really appreciate both of you taking your time to participate and your expertise and contributing that freely here. It means a lot to the OSCAL community and is really demonstrative of the kind of collaborative atmosphere that we really try to maintain. So thank you to all of our viewers, and we appreciate your time here learning about OSCAL. I hope you take time to visit our website at oscalfoundation.org and get involved in the technical working group if any of this is interesting to you, or if you have questions or want to talk more about OSCAL. As Brian said, we're out there, and we would love to talk to you about it. So with that, thank you, everybody, and I hope you have a great rest of your day. Thank you.
Thank you.
Bye.
Thank you all.